Assalamualaikum warahmatullahi wabarakatuh. We are members of the Biohazard group. We will be talking about our case study entitled "Can frozen corpses be brought back to life and made to look younger than when they die using stem cell injection?" Here is our members, including me, NURUL, FARHANA, Athirah, QAMARINA, AMIRA, SYAFIQAH, and the last one is ADLINA. The content for our slide is as follows. The first part of my speech will deal with the introduction of psychopreservation. Psychopreservation or psychoconservation is the process of preserving organ, cell, tissue, extracellular matrix, and any other biological construct which is susceptible to damage caused by unregulated chemical reaction. Psychopreservation is to preserve and store the viable biological sample in the frozen state over an extended period of time. We will then look at the history of psychopreservation. One earlier theoretician who proposed psychopreservation was James Lovelock. In year 1953, Lovelock proposed that osmotic stress caused red blood cells to die during freezing, and that increasing the salt concentration in a dehydrating cell could prevent it. In the mid-1915s, he experimented with the psychopreservation of rodents, determining that hamsters could be frozen with 90% of the water in the brain crystallized into ice with no adverse, and the effect other organs were shown to be susceptible to damage. That's all from me. Thank you.
Hi, Assalamualaikum. My name is Athirah and right now I'm going to present the structure and function of cryopreservation. So what is cryopreservation? Cryopreservation is a process that maintains biological samples in a state of suspended animation at cryogenic temperature for any considerable period and is used to preserve the fine structure of cells. So with the constant availability of cryopreserved cells and tissues, extensive quality testing can be undertaken to verify cells or tissues' suitability for transplantation without the need for fresh samples. Let's move on to the processes within cryopreservation. The first process is slow freezing. The second one is vitrification. So vitrification, which involves the solidification of the aqueous milieu of the cell or tissue into a non-crystalline glassy phase. So the third process is subrazo non-freezing storage, and the last process is preservation in the dry state. Because of the difficulties involved in delivering the disaccharide 3-hallose, which is the disaccharide of glucose, and amino acid into the intracellular region, mammalian cell cannot be stored in dry phase. So what is slow freezing? Slow freezing initially replaces the water in the cytoplasm with CPAs, reducing cell damage and adjusting the chilling rate in line with the cell membrane permeability. Slow cooling techniques use a high cost control rate freezer or a benchtop portable freezing container to cool at a rate of roughly 1 degree Celsius per minute in the presence of less than 1 mole of CPA. Slow freezing has the advantages of posing a low danger of contamination during processes and requiring modest manipulation abilities. Slow freezing, on the other hand, increases the risk of freeze injury due to the accumulation of extracellular ice. So what is exactly vitrification? Vitrification is a process by which cell suspensions are changed directly from the aqueous state to a glass state after directly exposure to liquid nitrogen. As an alternative to the slow freezing procedure, after being exposed to high concentration of CPA in the ratio of about 40 to 60% weight over volume, the cells of tissue must be cooled to deep cryogenic temperature, which is in liquid nitrogen, and then rapidly cooled to minimize the ice nucleation. Vitrification has a number of advantages, including a reduced danger of freeze injury, which ensure a high cell survival rate. However, there is a substantial risk of pathogenic agent contamination, and the approach necessitates exceptional manipulation abilities. So generally, the major steps in cryopreservation are: the first step is the mixing of CPAs with cells or tissue before cooling. The second step is cooling of the cells or tissue to a low temperature and its storage. The third step is warming of the cells or tissues. And the fourth step is removal of CPAs from the cells or tissues after thawing. So, what is exactly CPAs? CPAs, or we call it as cryoprotective agent, is usually a fluid reduce the freezing injury from the cryopreservation process. Let's refer to the figure 1. So, this figure shows the physical events and cryo-injury of cells during freezing and thawing. So, cryo-injuries are caused at least in part by the solution effect which lead to osmotic shock and intracellular ice formation which lead to breakdown of intracellular structure. So, let's look at the red box in the table. It shows the various CPAs have been developed and are used to reduce the amount of ice formed at any given temperature depending on the cell type, cooling rate and warming rate. In order to achieve the best survival rate of cells and tissues, the sample volume, cooling rate, warming rate and CPA concentration should be optimized depending on the different cell types and context tissues. So that's all for me, thank you.
Hello, my name is QAMARINA binti BASHARUDIN and I will present about the relationship of case study to physiology.
Exposure of the human body to cryogenic temperature results in many favorable psychological phenomena, such as analgesic effect, which is the most appreciated by practitioners. Second, increase in systemic immunity. Third, increase in serum beta endorphin, norepinephrine, adrenaline, testosterone, which is especially in men. Also, antioxidant effect of cryostimulation. Fifth, profuse flow of blood. Sixth, neuromuscular effect, which is increase of muscle strength. And lastly, overall improvement in well-being such as relaxation and physical relaxation. In addition, through the activity of the central nervous system, patients who underwent cryostimulation season in a cryochamber felt lower fatigue and a radical improvement in mood. Other observed effects include elimination of clinical depression symptoms and easier sleep, also improvement in sleep quality. Here I present the main direction of research and their results in terms of the effect of whole body cryostimulation on the body. First, motor activities and physical efficiency. Research by Zap carried out a large pool of athletes was meant to find an optimal operating temperature during the whole body cryostimulation for the improvement of motor skills. The effect of exposure were compared between 10 minutes whole body cryostimulation at negative 100 degrees Celsius, negative 130 degrees Celsius, and negative 160 degrees Celsius, and physical efficiency based on an assessment of agility, balance, speed, and dynamic strength of abdominal muscles. The results show the positive effect on human motor characteristics. Parameter evaluating the speed and dynamic strength of abdominal muscles improved most after the application of negative 100 degrees Celsius. The another effect of cryostimulation on the body is hormone. A single cryostimulation at negative 130 degrees Celsius causes increased concentration of a pro-melanocortin related hormone, endorphin, adrenaline, and noradrenaline in men and women, and a significant increase in testosterone in men. Literature data indicate that in elderly women, cryotherapy at temperature of negative 110 degrees Celsius to negative 150 degrees Celsius influence the level of bone composition markers, which is a decline in osteocalcin, increased alpha type 1 collagen in blood serum. Also, soccer players undertaking 10 sessions of cryostimulation followed by 60 minutes of kinesiotherapy had a significant decrease in the concentration of testosterone and estradiol. There were no changes in the level of LH hormone and the hydroxyprogesterone sulfate. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is AMIRA SYAFIQAH binti ABDUL and I will continue with the application of cryopreservation. There are actually a few other applications, but I chose to talk about two. One of them includes the bone marrow transplantation. In this transplantation, the patient's hematopoietic stem cells will be frozen and stored. When following the treatment, the patient's cryopreserved cells are thawed and infused back into the body. Cryopreservation of the hematopoietic cells has helped in the treatment of lymphomas and solid tumor malignancies. If you will take a look at the picture, you can see very clearly regarding the steps in this transplantation. So next will be the in vitro fertilization, or in other words IVF. It is used to freeze the human eggs, embryos and sperm. They typically use liquid nitrogen to freeze the sperm or embryos to negative 320 degrees Fahrenheit. The eggs, embryos or sperm will be thawed and fertilized to be used in fertility treatment cycle. This IVF is actually a very common way for couples who have experienced problem when trying to have a baby. Next, I'm going to talk about the benefits of cryopreservation. First off, cryopreservation helps in the preservation of bone marrow, sperm, embryos, and organs, which is very helpful for the people who have experienced pain in these areas. Next, cryopreservation can help couples that have infertility problems to overcome it and be able to have their own child. It can also be helpful for cancer patients or people with careers that can be life or fertility threatening to be able to freeze their eggs to ensure fertility and use it when and if they decide to start a family through IVF. As far as research goes, the use of cryopreservation in the organization of the human body, which goes cells, tissues, organ system, it has only been very successful in cells and tissues and have not quite reached organ, as the organs are more complex. So the classic cryopreservation that involves freezing, while it is successful for many isolated cells in suspension, has failed to provide the means of banking more complex tissues and organs. That is all from me. Thank you.
In conclusion, we all agree that cryopreservation brings more benefit to human reproduction and biotechnology nowadays and can make it possible to happen. With the help of advance in biotechnology, cryopreservation has shown an improvement in the freezing and thawing rate, osmotic condition, choice and concentration of CPAS, and equilibration times in the CPAS. The result improved that the survivability and functioning of human tissue and cell sample, allowing for effective future therapeutic use. A greater knowledge of chemistry and biology underpinning freezing and thawing will be required for future improvement of this technique and the discovery of the most safe and effective cryopreservation approach. The most important future aims of cryopreservation is the development of the process that have the least impact of the integrity of cryopreservation cell or tissue, followed by the standardization of optimizing of the technology for the routine application. The effective cryopreservation of biological sample may play a critical role in the clinical utility research for all types of human studies.